Okay, so we got the basic pan bottom built. So what we got here is my maple syrup rig. Now what I'm thinking is, instead of having one big pan, is possibly making two pans to fit these holes. Basically just looking at it in terms of efficiency. And I'm wondering as I'm wandering, if I can't make things better. Here, let me go get the pan and you'll see what I mean. So this is my maple syrup evaporator pan. Got a drain here on the front. But if you look, you can see that there's a lot of material here. That's 3.5 inches. 3.5, so there's at least 3.5 inches on either side of that pan that's not being in contact with the flame. So I've got two choices. I can cut this down, make two pans, or simply might be better off to cut this. Even if I keep this one pan, I'd be better off to make it smaller. The volume of liquid it holds is not as critical as the as its direct contact with flame and heat source from underneath in order to boil efficiently. This pan was originally not made for the stove, by the way. That's why it's oversized. It was made to fit a 6-burner propane range that I had. It's 2 feet wide by 36 inches long, so it's 2 feet by 3 feet. Surface area of the stove is 17 by 34.5. I kind of like the idea of having two pans. That way you can have one that's under here that's really underneath the fire pot and really boiled, and then you use this as the second one, and then you can feed or ladle the one that's a little cooler from one to the other. Probably the easiest thing to do is just cut that, keep the same concept, one big pan, but cut that thing down to fit the actual surface of the stove. Since I don't know for sure what I'm doing, I guess you'll have to keep watching, find out. Yeah, that blackened spot on the bottom of my maple syrup evaporator tells the story. There's a good 3.5 to 4 inch border all around the outside of that pan that's not getting exposed to heat. And that is really ruining my efficiency. So I'm using more wood, but most importantly to me, it's taking me more time to boil the sap down the syrup. So let's see what we can do about it. Last month when I made my buddy's pan, this was a piece, the other end was a piece. There were two bends, it's welded together, left the metal sticking out here, simply fuse the two metals together without using any filler rod. In the end, ground it down and I re-welded it using filler rod, but 90% I probably didn't do because it was already pretty good, but the corners were bad. This was not welded that way. This particular pan is made with 4 bends. Bend here, bend here, bend there, and bend there. And no weld on the bottom edge. These seams came together. I welded them to seam with filler rod. That's how that one was made. So I'll be rebending the metal, you'll be able to see. Pretty close to that back line. Make a new bend here, bend there, bend here, and bend over here. The very least I have to do is gotta cut. Can't cut the weld itself, it's too hard. Gotta cut around there, cut over there, and over here. And you cut about 1 inch away from the welds. So here I am looking at it with the ruler, finding the center, and figuring out the overall length I want. Going to cut it there, going to cut it up there, and make the same cuts on the other side with a mark. Cut that away, cut that. And as in the other previous videos with the hacksaw and stainless steel, I like to spray the part and the hacksaw blade with water to try to keep both the material cool and the hacksaw blade cool. It does do a reasonably good job of cutting the metal, but if you don't water it and keep it cold, it gets hot pretty fast. Here I am finishing it off. So this is the end with had the drain spout on it. I'm not going to use that anymore. That's now waste, so just set that aside. So with that done, I'm straightening out the other end. With my initial intention was to just bend that end on the near the black smoke there, the carbonized end. Now I have to bend the two sides. And you can do this to just about any piece of metal. You can bend it and then bend it back one time without any real concern. Here I'm using a hammer and a block of wood. Looking good. Okay, so we got the basic pan bottom built, and I put the bends up the top like I did with my buddies, but I added an extra lip here on the edge so that when you grab that, fingers are hanging onto there. I thought about doing that with the other pan, but in the end I didn't do it, and I should have. It can be done after the fact. Stainless steel is not all that hard. Even a pair of pliers and a little bit at a time. If you're watching art, you can do that yourself if you find it necessary. I think it's going to be helpful. Hopefully you can see this, but when you've got multiple bends here going on at the same time, trying to bend this, bend that, you can't do it in the brake because the body of the brake over here interferes. Now if I cut that back at a 45, I could do better, but typically what I do is I bend this a little bit to get out of the way, get the bend started to make the line. What I end up doing is bending it with a pair of pliers and then putting it in the vise. So in the end, I decided not to bend that other piece up and only weld two seams. I've made two end pieces. This is the first one in place. Got it clamped in half a dozen places, and it's a pretty good fit. I'm going to tack weld it in about half a dozen places and then probably leave it for the day. But that's a good start. Okay, starting to tack. Again, no filler rod. So from the previous video here, I don't want to show all these welds, but the concept is you put on a lot of little tacks. You got to fill all of those seams with tack welds at about ½ an inch apart. And then when you get that all done, you can take the clamps or vice grips off and basically do a seam weld with the torch and fill in all the unwelded parts. Here I'm trying the two different cameras with a welding lens in front, trying to give you a better view of the weld. There's another example. There's a different camera here. I think this one shows it better. And not to be outdone, show another example. I think that shows the two metals fusing together pretty good. Okay. So this is my own evaporator pan, rebuilt. Welded up. Time for the leak test. Perfect. No leaks at that end. Alright, turn it around. And no leaks at this end. Alright. Pans are ready for action, and it won't be long because snow's melting and the buckets are on the trees. I don't know if you can see them, but tapped them yesterday. So just to recap, just as much work rebuilding this one as there was making the first one for my buddy. But the whole purpose of doing this was custom fit this to my stove top. And once the sap is done and we're ready to boil, we'll show this in action, and that'll be the next thing you see. That'll be a couple of weeks from now. Okay, so the next moment of truth is to see how my new pan fits the top of the stove. Should fit pretty good because I measured it and everything. And looking at the base, there's not a whole lot of clean metal around the outside anymore, so it should be a pretty good fit. Let's get it on here. Alright. It certainly fits really nice on the sides. There's a little bit, only about a half an inch overhang there. And, well, maybe an inch or an inch and a half overhang here, but that's a heck of a lot better than it was. So this thing used to hold 105 liters. I think now it'll hold probably somewhere around 65 or 70. These things hold between 15 and 18 liters, so I should be able to get four of these bottles into there. But it's evening on a Friday. I just want to get maybe 2 or 3 of those in there, of these in there at the most. Get the fire going, and then I'll babysit this thing until 10 or 11 o'clock, and then I'll go to bed. I'll get up in the morning and start over. I need to do a double transfer here so that I can strain the sap one more time before it goes into the actual boiler pan. So, now that I got a good amount of weight off of it, I can hand bomb the rest of this into direct in. Okay. It's hard to tell with all the steam, but it's obviously boiling in the front, but it's also boiling through to the back, and that's what I was hoping for. Get a more thorough boil all the way across the boiler pan. So the pan fits the stove a lot better. Working good. Got the old wood stove going here. A good fire on in there. Mixture of pine and hardwood. Hope this shows up, but when it boils like that in tiny little bubbles over almost the whole surface, that's when it's getting close to the flash point. So I'm going to take it out of this main evaporator, transfer it into my finishing pot. So let's do that. This is the treacherous part. Well, that's it for another year. So to quantify things, or answer the question as to whether it was all worth it, it definitely was. I made more syrup this year than I ever had in the past, and boiled down, obviously boiled more sap down to make that happen. And I did it in about the same amount of time. So I'm boiling 15% more sap, and I used slightly less wood. So I think I would have to say that the efficiencies were improved in both regards. I'm saving on wood and saving on time. So yeah, it was worth it. It's kind of a it's kind of a strange thing, because honestly, I collect syrup for 2 or 3 weeks, but I basically only spend one day with this stove and that pan I built to boil it down and to make a product. So it's a lot of work to make improvements on something that you only use one day of the year, but the improvements were made. So I'm happy, and for years to come I'll get to use that same boiler pan and know that it's going to do the job. Anyway, hope you enjoyed the video, and we'll see you on another one. Cheers.